everyone. My name is Sarthak Joshi and I am a 2 month intern from Group 2 in infotact solution. I would like to thank you all for giving me this opportunity to present my work with you. Let me start. Here we have imported all the required libraries like pandas, numpy, matplotlib, seaborn, sklearn, and we have ignored the warnings for better representation. We have copied that dataset provided into variable data and df. Okay, we have dropped column customer id as it is not required for our dataset. Then we have mapped the gender as male for 1 and female for 0. Then we have made a new data set called features to make it standardized and drop the column gender from it. Then we have standardized the scalar feature. We have standardized the uh, attribute features and fit transform it. Okay. Then we have applied PCA fit transform it to reduce its dimensionality and make it less complex. Then we have done some data visualization part, like we have done a pie chart distribution showing the number of male customer and female customers. From this analysis we can see there are around 81% female customer and 19% male customer only. So from analysis we can say that the shop is getting more female customer than male customers. Okay, so here we have plotted an histogram saying number of customer placing the number of orders. Like for example, here from this plot alone, we can say zero number of order are placed by more than 8,000 customers. In case of Asus, we can say that there are more than 25,000 orders. There were more than 25,000 customers who have not purchased any Asus laptop or Asus brand's product. Uh, like for example, there are little over 25,000 customers who have not placed any order for MI, and 1,000 around 1,000 customers who have placed one order, and 300 to 400 customers who have placed two orders for MI. From this analysis we get the order count for each individual company. Next we have order versus number of count. Like we have this graph but bigger. Okay, we have or we have number of order versus count. Like 6,000 people have placed zero orders, 1,000 people have placed, like 2,500 people have placed one order. Likewise, and okay, now we have plotted a graph telling us the number of male customer and female customer who have placed the order. Like we can see, in case of Samsung, there are this many customers who have this many female customer who have placed the order, and this many male customer who have placed the order. In case of Asus, there is no male customer who have placed the order, and there are no company with more male customers than female customers. So in this graph we have shortlisted the top 10 companies who's with on the basis of sales. So in this analysis we see that JM's Mercer and Juniper, Blueberry, Scable, H&M, Essex, Jordan, Dior, Huawei, and Gatorade are the top 10 performing companies in terms of number of orders. And here is an order distribution for the companies. Like as we can see here, JM Smith have the maximum number of order, like 23,000 plus, and then Jupiter with little over 13,000, Blueberry with less than 12,000, and so on. Top 10 companies for each gender we have next, and we can see that the top 10 companies of male customer, like Schmuckers, Gatorade, Juniper, Asics, Jordan, Vars, Pop Chips, Samsung, Huawei, Brooks are the top 10 companies which acquire more male customer. And top 10 female customer brands are Schmucker, Blueberry, Juniper, Scabble, H&M, Dior, Asics, Huawei, Jordan, and Pop Chips. Here is here is an heat map for correlation matrix. We can see there are not many correlation between two attributes with maximum correlation with of 0.5, which is not that much, and we have not set the threshold. We have set the threshold at 0.6, so we had not gonna eliminate any of the attributes present. So we have implemented the k-mean clustering and hierarchical clustering. For this we have transformed the we have transformed the features to standardize it. The features we have separated from above are now standardized, and we have used WCSS method, which calculates the inertia of a particular number of clustering algorithm, and give us the best result. This is the elbow graph. We can see we get two elbows here, one for 2 and one for 4. So let's start with two number of clusters. We have we have made a model called mod 2 and predicted and saved the value in new uh, feature called 2 cluster count. And then we have made a graph saying we have made a graph indicating number of people in that cluster. So in 0th cluster we have 14,000 people, and in in one cluster we have 12,000 people. We have made a box plot as well to to analyze the data. We can from this box plot we can see the maximum and minimum value for that cluster. Number of order for maximum number of order for the cluster 1 is 12, and for cluster 0 is 4, while minimum order for cluster 1 is 5, and minimum order for cluster 0 is 0. With median of cluster 0 is 1 and median of cluster 1 is 8. And as we can see in this graph, 25% of the cluster 1 lies between 5 to 6 orders, and 25 to 15 percentile of customer lies between 5 to 9 orders, 5 to 8, sorry. For next 25% we have clusters 8 to 9, and from 10 above there are 75 to 800 percentile of the customers. We have plotted our graph. We have plotted cluster graph using PCA here. As we can see, there is this line which divides the cluster 1 with cluster another. This is cluster 0 and this is cluster 1. The elbow graph suggested we have number of clusters is equal to 4, so we have taken 4 number of clusters here and made a model called mod 4. These are the clusters 0 1 2 3 4, 0 1 2 3, not 4. and we have plotted the number of people per clusters. We get more than 10,000 in cluster 0, 8,000 more than 8,000 in cluster 1, less than 8,000 in cluster 2, and less than 1,000 in cluster 3. We have also plot and box plot for this clusters. This shows us median, maximum, minimum, and IQ1, Q2, Q3, Q4, Q3, 1, 2, 3, 4. We have plotted these clusters as well using PCA, and here it is the plot. Okay, now we have done a hierarchical clustering. For this, we have imported hierarchical cluster model. We have imported linkage, dendrogram, and F cluster. We have Hmm. Next, we have done the hierarchical clustering from next we have done hierarchical clustering. For this, we have imported linkage, dendrogram, and F cluster from SciPy, and we have increased the limit of the computation because of the larger value in data sets. So we have defined the linkage and data clustering. From this, we get, from the following observation of dendrogram, we get two number of clustering to be optimal number of clustering. So we have made a new cluster saying it is we have made a new cluster with number 2, number of cluster 2, and we have plotted it. So it is like this: number of people in cluster 0 and 1, 1 and 2, here 1 and 2, okay, are like this. In cluster 1 there are 13,000 people, and in cluster 4 there are 14,000 people. So we can see an quite equal number of distribution in these clusters. We have a k-map for better comparison, k-mean clustering with two values. The graph we have seen again reprinted for better observations. We can clearly see the difference between two clusters, two methods of clusters here. Next, box plot for hierarchical clustering. In this box plot, we can see the number of outliers are far too many, and minimum and maximum for each cluster is different. So it is not a good clustering algorithm for the dataset given. As we can see for k means 0 to 4 number of orders are in cluster 0, and from cluster 5 to 12 in cluster 1. But in box plot there is no such trend is followed. So in case of clustering based on orders, this is not a good clustering, and we will prefer this cluster over that. And here is 4 mod 4 cluster for side by side comparison. And thank you thank, thank you for listening.